Hey, good morning, class. We're gonna get started. Hopefully we have some people in our Zoom today. Hopefully you guys can hear me. Please let me know if you're joining. Let me type that down. Please email me if you're online. So that way I have it on writing. In case, for whatever reason, I want to make sure that you're online or in person, then I can just have it in writing. So today we're doing nonlinear equations using MATLAB. This is chapter 3 of your book. So I gave you this warm up. Go ahead and get started on this if you haven't already. And I'll give you a couple minutes for that. So I want you to do these by hand and then use MATLAB to confirm your results. See what you get. Okay, I'm gonna do the first one. So So we have A equals 1, 2, 3. One, two, three. Okay. Easy enough. B is 3. So can we multiply these? Yes, because A is an array. B is, what is B? Scalar. Good. So I'll define C equals B times A. That should work. Is that what you got? So far, so good? Now I'm going to change B. Now B is a vector. 4, 5, 6. Will this work? No, why not? So what is the size of A? Yep, it's right here. B is also 1 by 3. So when I multiply these, what's going to happen? Error. So why is there an error? Right, right. So what's the condition that the vectors have to be multiplied? That's right. So the inner products. So this number has to match this number. So how do we fix that? You can transpose it. So now will this work? Now we're doing number 3. Let me share my screen to the other. Let me leave this one. Let's see. Can you guys see that? Yeah. So now this should work, right? Okay. Does this make sense? B times A. Let's see, what is B? Yes? Is that what you guys got? All right. And then the last one. So we have 2 rows, 3 columns. 2 columns, 3 rows. So should number 4 work? All right. So is it starting to make more sense now about, we're talking about element by element, matrix multiplication. Sometimes you need the period, sometimes you don't. So this is the explanation. It always goes back to the math. The math is always what's gonna derive that. I think that you're in the Zoom rather than in person. What do you mean? You can see what I see. Okay. Yeah, so if you're online right now, just email me. If you're online, just email me. Okay, so try number 4. There we go. I don't know why I was getting a matrix before. For C, so C should be a scalar. So C is basically the equivalent of the dot products. for number 3. So we're dotting each of the components and then we're summing those together, right? So that was like your homework for week 1. So for number 4, same thing, right? You want to either do it by hand, take the dot product of each of these arrays, right? Or we can kind of cheat with MATLAB. 154, 63, 632, 12, 56, 43. Okay, so doing it by hand, you know, you can say it's a waste of time because why would you do it by hand if you can use MATLAB now? But you should do it by hand, you know, to see how the math is working. And, you know, MATLAB is just your calculator. That's just your computer. So, so MATLAB can be like a really good check and see if that makes sense. So we have 2 by 3, 3 by 2. So then does it make sense that C is a 4 by 4 or 2 by 2 rather? So how do we know that it's a 2 by 2? Because A is 2 by 3 and B is 3 by 2. So we need these 2 values. Okay. So what I went ahead and did is I did some homework, and then I think this is number 226 in your book. So basically, this is a user-defined function. It carries out the matrix multiplication of 2 matrices. So we define A, we define B, just like before. So we define A, we define B, and then it asks you to write a function, but I was kind of lazy, so I just made a little script. And so it takes in the input, which is 2 matrices. So we'll talk about functions next week, but we're taking this function, and then we have these 2 parameters, A and B. And then so what the script does, I'll show you in a second, it's going to take those values and then iterate through each of those indices, multiply them together, add them together, and then build a new matrix. So the way it works is first we can define our matrix A, right? Then we define our matrix B. So that's what we did before. And so MATLAB already has this built-in side, but it's good to do it yourself so you can see what's going on. Then I want to check the size of A, just so I can see what it is. In fact, let's suppress everything just to see what we have so far. I'm going to suppress the rest of this. I'm going to let you copy this if you want, but I think I won't be sharing it. So during the discussion, during the lab, I'll let you guys copy it, or you can watch the video, but I probably won't post it. So we have these 2 matrices. We run that. Let's see what happens so far. Okay, so we have A, 3 by 3 matrix. We have B, 3 by 3 matrix. And then we calculate the size. So we have 3 by 3, 3 by 3. Okay, so this is like the preliminary check that I asked you to do first. So can we compute it as long as the columns of the first matrix are equal to the rows of the second matrix, right? Rows, comma, columns. Now we can proceed. So then I have this script, right? So we have some conditionals. Raise your hand if you've seen conditionals. If statements, while loops, for loops, perfect. So if this condition is not equal, so you can do if it's equal if you want, then it says, oh, look, it's not going to work. We can't do it. That's not math. But if it is equal, then it says, yay, let's do it. So the way it works is we have a nested for loop. So that means a for loop within a for loop. So first we iterate through I, that's just the first index. We're iterating from 1 to the size of A of the first dimension. So in this case, they're both 3. So we're going from 1, 2. So in this case, what would it be? 3, because these are 3 by 3 matrices. And then J goes from 1 to so we want to make sure that it goes through each of these indices. So we go from I equals 1 to 3 and J equals 1 to 3. And then what we're going to do is multiply the values and then store it in an element and then build a matrix like that. So if this works, then what it does is calculates the matrix. We have, again, A equals that, B equals that. Now let's do some matrix multiplication. It does the operations simultaneously. So if this should work, then, you know, again, that's the beauty of MATLAB. This should work for, let's see if it just keeps working for as long as the matrices are the same dimensions, right? It should still work. So now we have, what is that, 5 by 5? Actually, that won't work because that's 3. That won't work. That's 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? Let's just check. And then I'm lazy, so, you know, in fact, let's just say B equals A. So press that, cross our fingers, see if that works. Yay. Cool, right? So we have A and B. And then now I can cheat. If I have some homework assignment, says multiply these matrices, you know, I can use Google or I can use MATLAB. And this is only for matrix multiplication. So hopefully by, you know, a couple weeks from now, this code will make a little bit more sense to y'all. And then you can make your own code for the numerical methods, right? So that's what today is going to be about. We're going to be kind of learning sort of how to kind of build this. Instead of doing matrix multiplication, we're going to be doing numerical methods. Make sense? So what are numerical methods again? So remember, sometimes we can develop an equation and it's easy enough to solve, but sometimes the equations are kind of difficult to solve by hand, right? So that's where MATLAB comes in. Any questions? All right. Enough of me just kind of with this warm up. So hopefully, you know, guys wake up by now, get started, take out your notes. We're going to be covering basically all of chapter 3. We've done a lot so far. Chapter 1, chapter 2, and chapter 3. I'm a little bit behind. So hopefully now by this week, we'll catch up with your lecture. Because week 1, you guys did like 3 chapters. Then week 2, you already started chapter 3. So now we're catching up to the rest of the lecture. And then, you know, again, according to the syllabus, it's about a chapter a week. So keep that in mind. And then, yeah. Did you guys have your quiz? Not yet? So it's next week? Tomorrow. Okay. All right. So remember, it's going to be mostly on chapter 1, chapter 2. So just review your matrix, you know, computations, and then hopefully review a little bit of today for chapter 3. All right. Any questions before we get started? Yeah. So again, if you want to see the code for what I just showed, you don't have to worry about it. You're not going to need that for the class, but if you want to see it for your reference, I'll be leaving it up on the board during the lab. All right. So again, chapter 3 covers lots of different stuff. We're going to be starting with the background and basically deriving the equations for the estimation of errors. And so once we have those definitions, we can define each of the methods: bisection, regular false line, Newton's secant, fixed point iteration, equations with multiple solutions, and systems of nonlinear equations. The focus, chapter 3, focus on the methods. So we're doing bisection method, regular falsi, and Newton's method today. Whatever I don't cover doesn't mean that you don't have to know it. So if I don't cover it today, go to your book, make your own methods, make your own scripts. I have office hours tomorrow. If you want to come by, show me your scripts, because you're going to be tested on these methods, either on your quiz or you're going to need them for the rest of the class. So I really want you guys to build your own scripts so that in the future, right, you have to solve some methods, you already have them already there. And then you can kind of cheat, right? Cheat, air quotes. So that means, you already have the scripts there ready for you. All right. So the main idea, let's just take it all the way back. Sorry. Take it all the way back to like high school. So we have, in this case, what kind of function is this? Quadratic function. And so given these parameters, so what is a parameter? Yeah. In this case, it's ABC. So parameter is going to be one of the inputs that adjusts the function, right? So in this case, your parameters are the coefficients A, B, and C. So if I give you A and B and C, can you solve this equation? Yes? How do you do that? Quadratic formula, perfect. Okay. So the first step is going to be setting the function equal to 0. Why do you set the function equal to 0? Find the roots of the function. Okay. So what is the root? What does that mean? The x-intercept. Very good, because f of x equals 0. So the premise for this chapter is we have some function, some unknown function, or some known function, and we have some parameters, and then we have the variable. So we want to set some new function f of x equal to 0. That's the first step. That's really key, because sometimes you have a function, you need to figure out what you want to set it equal to 0. The second step is now, well, let's see if we can do some math. Before we do MATLAB, let's just see if we can do math. Get some analytical solution. So what's an analytical solution again? Yes, an exact, analytical, an actual function, an actual equation, right? So if we can do that, then we're good. Then we can solve it and then check. So in this case, we have, of course, the good old quadratic equation. And then the last step is to verify the results. So how do we verify the results? Exactly. So now you solve for x. If you have x, you should plug it back into the function. And then what should it be equal to? 0. Right? So we're not doing anything different than you've already seen hundreds of times by now. You have some function, you set it equal to 0, you solve that function, and then you verify the results. Okay? So before we get to the numerical methods, let's make sure we get this down. So I'm going to give you the parameters. Say A equals 1, B equals 4.2, C equals minus 3.7. Instead of doing this by hand, I know you can do this by hand. Do it on MATLAB. I'll give you 5 minutes. So solve it analytically first. Okay, so we have our parameters we can define. A equals 1, B equals 4.2, C equals minus 3.7. Okay. So what do we type? Negative b plus or minus the square root. So how do we do plus or minus in MATLAB? Right. So first let's call this one x1, and then we do plus square root of b squared minus 4ac all over 2a. Copy, paste, x2 minus. Is that what you got? x1.7. Yes, raise your hand if you got this. Okay. Give you a second to copy that down. Right, so this is nothing new compared to math. The only thing that's new is the syntax. But that's okay. It takes time to learn any language, including computer languages. Right? So what's another way we can solve this? We did this analytically, and we're about to learn how to do it numerically. What's one more way we can solve it? Graphically, geometrically. Exactly. So I'm going to suppress this. So now we know the answer. So let's pretend we don't know the answer, so we can see what's going on. So now I want to plot the function. Plot the function. So how do we do that again? So we can build a vector, right? So last time I told you about the brackets. This time I'm going to teach you linspace. Hopefully you've seen this, it's in your book. So linspace, we start from x1. So let's just pick an x1. Let's go from -10 up to 10. And then the nice thing about linspace is I can have the number of intervals. So I want it to be really nice and sharp and crisp. So I'm just going to say 10,000 or something, whatever you want. 100,000. Okay. And then suppress the output, because now this is a really, really huge vector. So now this is where the semicolons come in handy. Otherwise, it's going to take forever to compute. So now I'm going to define some function, f of x is a function of the input, right? Just copy that. F of x. Well, now what do we have to do? Let's go into the function and add our. No, that's not correct. It's not correct. I'm not solving for x. Defining the function. F of x equals this guy, right? This guy. So f of x, call it f of x equals a. So now what do we need? The period. So why do we need a period in this case? Element by element. Okay. Ax squared plus bx plus c. Again, suppress the output, otherwise it's going to crash the computer at some point. Okay. If this works, let's see if this works. X, f of x. Let's run this. Invalid use of operator. Ax squared plus bx plus c. Okay, is that what we expect? Is that what quadratic functions look like? Okay, so that's good. What we can do is start to make this, we can learn how to make things look a little pretty. So I also want to teach you anonymous functions. So what I'm going to do is I'm going to comment this guy. Okay. So I want to define an anonymous function. Okay. So an anonymous function is just a function. It's just a function. So the nice thing about that is I don't need the period. So if you're confused about that, I can just get rid of those. And so I can define the anonymous function as a function of x. That's the only key thing. You need to define the anonymous function as a function of some input. So right now, in this case, it's x. Maybe for your homework, it might be volume. It might be pressure. For the chemies, it might be flow rate for the environmentals. So that's your input, right? So that's that. And so I don't need to define x. I don't need any x thingies. The only thing now I just need is f plot. So f plot is slightly different. We're going to plot it from, we're going to plot the anonymous function, and then we're going to plot it from the interval. If you forget, how would you know? What are all these parameters? I forgot. Is it interval, x1, x2? I'm confused. Where do you go? Google. Where else? Textbook. That's more than enough. Google has everything, right? So just look up Google anonymous functions. So let's plot it again from -10 to 10. Let's see if that works. Okay, same thing, right? So this is no difference. Two different ways of solving the same thing. But sometimes anonymous functions can be useful. So we'll see why in a second. Again, let's make this a little bit prettier. So I want to, let's make it blue. Let's make it a little bit thicker. Okay, right? And I want to define the x-axis. Plot the x-axis. And I want to show the grid. I want to show the grid. Show the grid. Plot the x-axis. So it's going to be similar. F plot from -10 to 10, 0, 0. Let's just make it black, and let's make it, okay. See if that works. Need to do hold on, show both figures. I'm gonna close that, run it. Okay, great. So now we can see visually. So now I have the graph. Again, we could have used any other software to do so, but now we know how to graph things, so might as well just do that. So how do we solve, let's say I want to solve, typically, you know, in engineering, if we get a negative number, especially in chemi or NV, it's probably not right. Can't have negative pH, can't have negative concentration. So we're gonna ignore that point. And let's say we wanted to zoom in on this point. So I'm going to define the left and right bounds. Make sure it's above the anonymous function, or at least above the axis. So I'm going to say A is approximately, where do we know it's not? So I'll just say -2, and then I'll go up to 5. Okay, so -2, define the left bound, and then B equals 5. Define the right bound. So now I'm making we're doing the same thing, we're just making it more and more and more complicated. So now this is the left bound. Okay. And then now I'm just going to zoom in from A to B, plot from A to B. Actually, we can, yeah, let's keep that A to B. Do I have a bug? What line? Find the left bound. Got you. Got you. Got you. Got you. Let's change that. X left. Thank you. X right. This is left. Right. Left, left, right, right. Close that. Thank you for that. Okay, so now we're zooming in. So again, this is why this gets fun now. So now we can see where it is. You can see visually. We can guesstimate, that's fine, but you know, might as well get a little bit closer. X equals 0 to 2. Getting closer, probably have to close it. So it'd be nice if I can just, you know, have like a slider and then it zooms in automatically. I can guesstimate further, 0.5 to 1. 0.5 to 1. Close that. .7 to 0.8, right? Just keep doing that. But this algorithm kind of just it sucks. So the algorithm is basically like retyping the values and then checking that every single time. It is going to work because you can see it visually. But what's another way of doing this? So this is where now, this is what this class is about. Let's learn how to do everything we just did in the past 30 minutes, but we do it much more efficiently. Okay, so let's jump back into the PowerPoint. Any questions about the code? So I'm throwing a lot at you because I want you to kind of learn from this and then make your own code. This is just my style, and then you can have your own style. All right, so now let's learn how to make these algorithms better. The way we do that is through numerical methods. So what's the step for numerical methods? It's iteration. So the first step is to guess, and the second step is to check. So the algorithm that we employed was pretty poor because we were just kind of arbitrarily choosing the left bound and the right bound, and that just takes too long, right? So let's learn some better algorithms. So before we do that, let's talk about errors. We have all these definitions, all these lovely definitions for these different definitions. So we can read this, but what this slide says, this is like section 3.2, I think. Basically, all this is saying is epsilon is delta y and error is delta x. That's all it's saying. So we have all these fancy variables. All we care about is which one is delta x, so we can get closer and closer to the x-axis. And then epsilon is getting closer and closer to delta y. So remember, the goal is to shrink down as we approach the limit. Remember last week we talked about limits and derivatives. We're getting closer and closer, shrinking it down to 0. And then we're telling MATLAB to do that automatically. All right, any questions about these? Okay, a couple other things. Again, same thing, have some fancy definitions. All I want you to think about is X is your guess. So this is like when I was doing it right now, where was the left bound, where was the right bound? Let's shrink it closer and closer together until we get to the true answer. And then f of x should be equal to 0. We can calculate the error. So my guess is that you're going to be tested on the error because it's very testable. So make sure you understand how to define the error. But the main premise is this equation. So what is this equation? Yes, it's the mean. So we just add up everything divided by the number of terms. In this case, how many terms? 2. So we just divide by 2. So we just add up the terms themselves, divide by 2. And then that's just getting the average between the 2 points. Perhaps in the future, you might have some weighted means. When you take you're taking fluids, that's perfect. Fluids is a great class to take this quarter because you're going to have equations that look like this with some fancy squigglies called integrals. But all it is just, you're just adding it up divided by the number of terms. So mean is like, super fundamental. And so we can apply it to this class as well. Okay, first method we're going to talk about is the bisection method. So we kind of did a very poor version of the bisection method. The first step was to choose an interval between A and B such that f of A times f of B equals 0. So what does this equation mean? Why is this true? Where does this come from? Could be a good question. Let me double check that real quick. Should be less than 0. Yeah, typo. You're right. Right. Let me fix that. Sorry. Yes. Right. So why is f of A times f of B, why should that be less than 0? Yes, exactly. So let's look at the figure. So here's our function. So here's f of A. Suppose f of A is some value. Is it positive or negative? This one? Positive. So let's say f of A is 3, and then f of B is -1, right? So positive times a negative is going to be negative. So less than 0 means it's negative. Greater than 0 means it's positive. So all we're doing is we're taking the average of the 2 points that we defined. You can define them arbitrarily, or you can define them graphically, however you define them. And then you calculate whether or not it's between A and X and S, or between X and S and B. So instead of a demonstration, instead of an example, what I just showed you was sort of applying this method, okay, graphically, a little bit of the intuition. Yeah, any questions about bisection method? So instead of bisection method, what I really want to cover is regular falsi. But before we cover regular falsi, I really want to cover Newton's method. Newton's method is apparently the most applied of all the methods. While reviewing for this lecture, I learned that even today in modern research, people still use Newton's method, but just fancier and more robust, and basically using it to solve like really cool computer science stuff that we don't have to learn about. But anyway, you take the derivative of the function. So what's the derivative? You take the slope, right? You have your initial guess, and then that slope, you bring it down to the x-axis, and then you go back up to the function, take the derivative again, go back to the x-axis, go back up, derivative, right? So in theory, would this approach actually give you the true solution? No, why not? Because to get the true solution, we would have to take the limit as x approaches 0, and then the dx approaches 0, right? So we're getting estimates. Remember, this class is numerical methods, so we're not getting the true value. We're getting really close to the value. Why? Because all models are wrong and some models are useful. So we're trying to get this value. So again, just because I didn't cover it today doesn't mean you don't need to know it. Please review this one. Please learn how to derive the equations. And then the assignment should cover this one as well, actually. So you choose your xi rather arbitrarily. You plug in the equation. So where does this equation come from? From the book, good. So it's from the definition of the derivative. So all we have to do, move x to the other side, divide both sides. So f prime of x is equal to f prime of x equals, yes, dy dx. So we're just doing some algebra to move that around. That's all this equation is saying. So it's very simple, but very powerful. Okay, the one that I do want to go over is regular Fossi method. Okay, so I'm going to, please, let's do this one. Okay. And then cover that one. Okay. So, let's do this. Let's do this. Start video. Yes. Hopefully you can see that. And I'm going to stop this. Hopefully you can see that. Okay. To the chat, it's going to be a little difficult to see, but hopefully we can make it work. Let's cover that one actually, and then turn on the left one. That one. Let's do that. Try that. All right. Okay. So then let's just do the example we just did, right? So I'm gonna run that. Okay, so first let's get that from -10 to 10, run that, and then plot that. F of x, x, Okay, you can kind of see that, right? In chat. All right, you guys can definitely see that. That's perfect. So what is A? A is 1. B is 4.2. C is -3.7. So MATLAB will let us plot it. Goes from 0, covers from up to 0. Should look something like this. Okay, so that's our function. And so the goal is to get this point. It's the goal. That's the goal. We want to get that point. So see, how do we do that? We basically define the A and B. So step one is define so the algorithm, C bisection method. The reason I chose to do regular falsi is because the book does all the other algorithms and regular falsi is the same as the other ones. So let's go back to bisection real quick. First, choose an interval. So let's let A equal to like -2, right? X left equals -2, and then X right equals 5. So we're going somewhere. Let's let it equal -1, just in case. And then we're going somewhere right here. So this is X left 1, not. And then somewhere right here is X left 1. So this is the regular falsi method. So now we're doing this one. And so let's check out this figure. What we have to do is draw the secant line from f of A to f of B. It's gonna go way over there. Well, let's just say it's over there. If I do this better, that's where it would be. I'm just gonna do that. Okay, so we have the secant line. So notice what happened to the secant line. Where did it cross? Yeah, so this is our first guess. Okay, so is it correct? No, why not? Yeah, because it's just our first guess, so it's not going to be right the first time, right? Let's make sure. Okay, but this is the equation of a line, right? This is the equation of a line. What is the equation of a line? Yeah, perfect. So how do we get? All we have to do is use these points. We have 2 points, right? We have x and f of x, 1, and x2 and f of x, 2. So how do we go from 2 points to the equation of a line? Yes, first step is to calculate the slope. What is slope? Yeah. Let's call it f of x on the right side minus f of x on the left side divided by the right minus the left. So this should look like rise over run. Right? Raise your hand if you're still with me. Okay, perfect. What's the next step? So that's our function right here. Yes. How do we get the intercept? Okay. Before I continue, let me just double check. Right. So if we want the intercept, we need to solve for f of x equals to 0. So what are we solving for now? Visually is going to be that point. Okay. Okay. So I'm just going to give you the equation. I don't want to make a mistake. So I'm going to give you the equation. Just going to write that down. Basically, you just manipulate this equation. You plug that into here, do some algebra, and then you'll get B equals f of A minus slope. Okay, and then you plug it back into the function. So now we'll have, this is our full equation. B minus A, x minus A, plus f of A. This is all algebra. So this is that equation. That's the same equation. So all we did was use the equations from a line, did a little bit of algebra, and then we have the equation for a function. So this is just the same exact thing as mx plus b. This is your m, right? So all we have that's different now is just we have it as a function of the 2 points. And then we have the x and s. So that's our first iteration. Okay, so after that, we're pretty much done. Again, do some more algebra. Do some more math. We'll get to that equation. So if you want to check, just ask me after class. F of b minus a divided by f of b minus f of a. Okay, so those are 2 equations. So it's actually slightly different than that. They're equivalent because the a's and b's are arbitrary. So my equation is slightly different, but mathematically it should be correct. Any questions? Okay. So that's basically how to derive the equations. The question is how to do it in MATLAB, right? So I want you to get started on the assignment, see if you can do it. I'm going to wait 30 minutes, and then if you need help, I'm going to show it on MATLAB. So basically, remember, all we're doing is we're just selecting an interval, and then whatever equation we derive, that's our equation. And then we determine the location of the solution. Okay? Let's look up the assignment. Okay, so the first problem is what I just covered, regular falsi. So you can either, so I'm trying to be nice to y'all. Some of y'all get the scripts really quickly, and some of you takes a little bit of time. That's okay. Of course, you're not expected to know right away. But this time, I want you to do everything in MATLAB. So you can either do it by hand, like I just did, and then we iterate, right? Get closer and closer, and then do that on MATLAB. Or you can build a script. So you can do what I did when I showed you earlier. You can define the for loops. You can define your conditionals. As long as it works this time, I'll accept full credit. I encourage you to try to make your own function, your own robust algorithm, because next week, maybe I'll be a little bit meaner to you. We'll see how it goes. So this one is going to be the exact same example in your book. So your book already covers bisection method. So if you want, you can copy the code from example 1 and then adjust it to regular falsi. Change a little bit. This one, I want you to do Newton-Raphson. So again, you can do it manually. Just iterate a couple times. You can use MATLAB or use the for loops. If you have questions, please let me know. I'm going to wait 30 minutes, and then if you guys are still really stuck, then I'll go ahead and help you out with the algorithm. Before we get started, there are a couple things I do want to say. If you're doing for loops, make sure you know how to stop the for loop. Otherwise, the computer is going to be mad at you. So Windows is Control-C. Mac, I think it's Command-C. Please make sure you do that. That's going to stop it right away. So everyone, memorize that. Get a tattoo, because the last thing you want is on your exam, you know, you're iterating, and then your computer is just not happy. Windows Control-C, Mac Command-C. I believe so. Please check that. Couple other tips. So again, I want you to write your own numerical method with a robust algorithm. So what's an algorithm? Not the YouTube algorithm, not the TikTok algorithm. So an algorithm is just the list of steps, right? You're doing the list of steps. Step 1, you initialize it. Step 2 to 4, you're repeating, and then you tell it to stop. Okay. So what does it mean to be robust? Okay, strong. So a robust algorithm means that, yes, it works for the MATLAB grader examples. Yes, it works for your MATLAB assignments, but I want it to be robust so that it works after this class or for your homework for your other classes. Make sense? So keep iterating through that. Last week, someone asked me a really great question, and it's basically, how do you know to code that? How do you know to use that, that vector here? And, and that's just like asking any other language. How do you know to use this sentence or another sentence? It's a language at the end of the day. So you just have to get used to it, get accustomed to the language, and over time, it will make more sense. Also, someone asked me, why should we spend time making our own algorithms if the last section of this chapter has a built-in MATLAB function called F0 that, again, will give you the answer. But if you use F0, I'll give you 0 credit. So why are we reinventing the wheel? Because that's what this entire class is about. All of these algorithms, people have already spent their lives doing. Newton's method, Newton died how many years ago? So you're not really doing anything new. But by all means, if you do make your own algorithm, and let me tell you, if I get an email a couple of years from now, hey, Andrew, I made my own algorithm, I published this paper, yeah, I'll be really ecstatic for you because, this is just learning how to reinvent the wheel. But then after this class, that's when it really matters. Yeah, so just develop your own algorithm, make it more and more robust. And then I encourage you to use MATLAB for your other classes. So now you learn how to make calculators. So again, in your fluids, in your mass transfer, you're gonna have lots and lots of parameters that they're gonna ask you to iterate or do it lots of times. Advanced thermo too. It can be really annoying, but MATLAB helps you cheat, quote, cheat, okay? And remember that there's an infinite number of ways of solving the same problem. So yeah, if you see one method that you're confused why it worked, just know that you can get to the same answer. And then finally, this is just me nerding out real quick because just yesterday, this beautiful video came out, 3 Blue, 1 Brown. And I was like really surprised that, we're learning this simple equation and then it can be extremely, extremely beautiful, extremely geometric. So you can check that out. And yeah, so that's pretty much it. Get started. Let's see how it goes. And then again, if we're running out of time, I'll try to give you some tips. But I really want to see half of the green by 11 a.m. Okay, so I want you to finish this before you leave. And then if you finish early, finish your homework for this week. And then if you finish really early and you're really bored, then come show me your code. And then maybe I'll let you slide. So try to finish this by today because I asked the Friday class to not start until Friday. So hopefully you guys have the same amount of time. All right, that's it. I'm gonna stop.